Two functions f and g are defined for x an element of R as follows: f such that x maps onto 2 to the power of x, and g such that x maps onto 9x minus 3x squared minus 1. Now, we don't have to use this notation here. We can just say f of x equals 2 to the power of x. And we can say g of x equals 9x minus 3x squared minus 1. Now we want to complete this table and use it to draw the graphs of f and g for x lying between 0 and 3. To get f of 0, we just have to put 2 to the power of 0. Well, any number raised to the power of 0 is 1. 2 to the power of 0 is 1. To get f of 0.5, we have to get 2 to the power of 0.5. This is actually the same thing as the square root of 2. I will write these down to one decimal place, because if we look at the scales here, it's not going to be that easy to work with two decimal places. Now let's look at g of x. We have to get g of 0, so we plug 0 in for x. Well, 9 times 0 is 0, 0 squared is 0, so we just get minus 1 for g of 0. What about g of 0.5? We replace x with 0.5. So we have 9 multiplied by 0.5 minus 3 multiplied by 0.5 squared minus 1. So we get 2.75. To get g of 1, we have 9 times 1 minus 3 times 1 minus 1. Well, that's just 9 minus 3, which is 6. 6 minus 1 is 5. What about g of 1.5? We have 9 times 1.5 minus 3 times 1.5 squared minus 1. That's 5.75. I have decided to write down the values of g of x to one decimal place. Now I'm going to plot f of x in red. F of 0 is 1. What about f of 0.5? Well, where is 0.5? Well, this is 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tiny squares. So halfway is 5 tiny squares. 1, 2, 3, 4, 5. So this is 0.5 here. And at 0.5, f is 1.4. Well, 1.4 is just a little bit below 1.5. So 1.4 is about here. What about f of 1? F of 1 is 2. F of 1.5 is 2.8. So we go up to 2.8. That's close to 3. F of 2 is 4. F of 2.5 is 5.7. Which is about here. F of 3 is 8. 2 cubed is 8. Now let's look at g of x. G of 0 is minus 1. So when x is 0, g is minus 1. G of 0.5 is 2.8. 2.8 is close to 3. G of 1 is 5. G of 1.5 is 5.8. G of 2 is 4. I'm sorry, G of 2 is 5. G of 2.5 is 2.8. Yeah, we can see the symmetry now. You can see the symmetry in these values for g of x. That's the case for a quadratic function. Quadratic function has x squared as the highest power of x. So the rest of it is symmetrical. G of 3 is the same as g of 0. g of 3 is minus 1. The more usual way to write a quadratic function is to write the x squared term first. See, the x squared term is written second here, so we write it first normally, then the x term, and then the constant. Quadratic functions are U-shaped. Well, the shape is actually called a parabola. It's either an upright parabola like that, or it's an inverted parabola. This particular one is an inverted parabola. We know it's inverted because the x squared term is negative. See, we have a minus sign here, so that's how we know that it's inverted. In part B, we want to use the graphs to estimate the value or values of x for which 2 to the power of x plus 3x squared minus 9x plus 1 equals 0. Now, if we look at this equation here, we see that it's got from equating f and g with each other. If we put f of x equal to g of x, we will actually get this equation here. You see, f of x is 2 to the power of x. G of x is minus 3x squared plus 9x minus 1, if I write it like that. Of course, the x squared term was written second in the question, but normally a quadratic function is written with the x squared term first. Okay, so if we put these equal to each other, then we can move the right hand side over to the left hand side. And if we move the right hand side to the left hand side, we have 0 on the right hand side. So you see that solving this equation here that we're given in the question is equivalent to solving the equation got from putting the two functions equal to each other. So what does that mean geometrically? Well, where the functions are equal to each other, are the x values for which the functions are equal to each other, are the x values of the points of intersection of the two graphs. This value here looks very like 0.25. It's halfway between 0 and this point, which we know is 0.5. So you can see that it looks like f of 0.25 is equal to g of 0.25. So for this value of x, we have that f of 0.25. Actually, I'll use the color coding. F of 0.25 equals g of 0.25. Okay, the y value of this point, if we go across here, it looks like it's about 1, a little bit more than 1. But anyway, we're interested in the x value, such that f of x equals g of x. And we have another x value over here. Well, we can see that we have 2.5 here, and each of these tiny squares is 0.1. So we have 2.1, 2.2, 2.3, 2.4, 2.5. This value here is halfway between 2.1 and 2.2. Well, what's halfway between 2.1 and 2.2? What number is halfway between those numbers? Well, it's 2.15. So this value here appears to be 2.15. So, in other words, f of 2.15 is equal to g of 2.15. So we want the values of x, so the answer to part B is x equals 0.25 or x equals 2.15. If you want to see the exact solutions of this equation, you could type it in here. Here we have 2 to the power of x plus 3x squared minus 9x plus 1 equals 0. So here's the input. And if we scroll down here, we can see the two solutions. Now, I got 0.25. Well, the correct answer is actually 0.269. And I also got 2.15. well, here we have 2.156. So the values that we have are accurate to 1 decimal place actually. I've written down the true values here to 3 decimal places. So you can see that to 1 decimal place, the values that I got from the graph are 0.3 or 2.2. And to 1 decimal place, the true values are also 0.3 or 2.2. So to 1 decimal place, these values are spot on. Let k be the number such that 2 to the power of k equals 6. Using your graph or otherwise, estimate g of k. Well, let's see where 6 is on the vertical axis. We want 2 to the power of k to equal 6. So this is the graph of 2 to the power of x. So 2 to the power of this value here, whatever it is going to be 6. So this is the value that we need to look at. Well, it looks like this value is 2.6. So we can do a check of that. If we work out f of 2.6, that means we put 2 to the power of 2.6. And we get a number that's quite close to 6. Let's get the exact value. How do we solve the equation 2 to the power of k equals 6? Here's a case where we have to use logs, because what we're looking for is a power. To get at a power, we get the log of both sides. So we write log in front of both sides. And then we use one of the rules of logs, which tells us that we can take this power and write it down in front. So we get k log 2 equals log 6. K times log 2 equals log 6. Now we can get at k, because k is multiplied by log 2. So we take log 6 and divide it by the log of 2. So you can use this log button on your calculator, or you can use this button here called ln. ln stands for log to the base e. This button stands for log to the base 10. Now, if you haven't seen logs before, I won't talk about it. It's in the algebra playlist. You know, you can just follow the steps here. It's quite straightforward if you don't know the meaning of logs. You can use either this button log, or you can use the ln button on your calculator. So I'm going to use log. So we get the log of 6 and divide it by the log of 2. So we get 2.5849. So this value that we get to 1 decimal places, this value is actually 2.6. That's the value we saw on the graph. I'll write this down to 3 decimal places. So we have 2.585. Now I could have used this ln button. I'll just show you with ln. I've got ln of 6 and divide it by ln of 2. You get the same answer.